Welcome to EDU World Space.
So this is a work done problem. So anytime you hear about work done, it refers to the distance between two charges. So it depends on your two charges and the distance between them. So in this question, we know there are four charges in place here. Your Q1, your Q2, your Q3, and your Q4. And the distance between, let's say, Q1 and Q4 by just using So Q1 and Q4, you're taking Pythagorean theorem, you have the square root of 2a. Similar is also similar to the distance between Q3 and Q4, which is also square root of 2a. So the distances are similar, they're the same. So now we have to figure out the work done for U1, uh, the potential U2, U3, U4, and U5 and U6. So for So for the work done on Q1, Q2, we know is the potential U1 is the potential energy between Q1 and Q2. So U1 is the potential energy between charges Q1 and Q2. U2 is the potential between Q1 and Q3. U3 is the potential energy between Q4 and Q2. U sub 4 is the potential energy between Q3 and Q4. Is the potential energy between Q1 and Q4. And U6 is the potential energy between Q3 and Q2. So essentially what this is telling us is that Q1 is equal to Q2, which is also equal to Q3, which is equal to Q4, and Q5, which is also equal to Q6. All all of those Q's are all equal to Q. So the Q is remains the same essentially, right? So now we have to figure out the total work done acting on each charge. So total work done, W, is equal to U1 plus U2 plus U3 plus U4 plus U5 plus U6. And potential energy for U1, U2, U3, U4, etc. is negative constant K Q squared over A, where K is equal to 1 over 4 pi epsilon sub 0. U5 is equal to U6 so K Q2 over the square root A of 2. Let's call it equation 2, equation 1, and equation 3. So now we're essentially adding all the work done. So W for U1 negative KQU Q squared over A plus negative K Q squared over A plus negative K Q squared over A plus negative K Q squared over A. So that's the potential for acting on the potential energy acting on each charge Q1 to Q4, U1 to Q4. So for for U5, which is the same thing as U6. So K Q squared over the square root of 2. So now it's just all about simplification. W, because the work done for both Q's 1, 2, 3, 4 take like terms. The denominator is the same, so you could add them. So doing that, you have negative 4 KQ squared over A. U5 and U6 have the same denominator, so you could add those plus 2 KQ squared over the square over A square root of 2. We can't, according to algebra, we can't have the square root of 2 in the denominator. So you could conjugate that and ensure that the square root stays the same. So essentially, you're multiplying this fraction by root 2. You're multiplying the denominator by root 2 and root 2. So doing that, you have negative 4. The root 2 cancels out in the denominator. On top, you have the square root of 2 KQ squared over A. Same same denominator, so you could add them. So you have A. You could factor out the KQ squared. you're left with negative 4 plus the square root of 2. So the square root of 2 minus negative 4. Now you can factor in your values for k, which is your constant. K is k, as we know, is given by equation 2, 1 over 4 pi epsilon 0, E0, sub 0. And we know what our q is, right? Our q you know they're all the same thing. It's 2.30 pica. So 2.30 times 10 to the negative 12 coulombs. So K 1 over 4 pi E0 times 2.30 times 10 to the negative 12. If you multiply, remember, if you expand this, so KQ squared times radical 2 and KQ squared times negative 4 KQ squared. So you're also going to have the same thing. So times 1 over 64 times 10 to the negative 2 times radical 2 minus 4. So work done. Go ahead and input that into your calculator. You should be able to get negative 1 point. You should be able to get negative 1.92 times 10 to the negative 13 joules. There you have it. That's your answer.